Hello out there, welcome to this tutorial. It's on the cone. So in this video we'll be looking at properties, net, surface area and volume of a cone. So we look at first the properties of a cone. A cone is a three-dimensional solid shape. It has two faces, the circular base and the curved surface. It has one curved edge and one vertex. So this is demonstrated here now. This is the circular base, the curved surface, and this is the vertex. So this is the curved edge, the net of a cone. If a cone is dismantled and separated into its components, we will have one circle from the circular base and a sector of a circle from the curved surface. So this is shown in the diagram below. This is the circular base and this is the curved surface. So this is the net of a cone. Then we go to the surface area of a cone. Given the cone below with vertical height h units, slant height L units, and radius R units. So we look at the area of the circular base. Since the base is a circle, it is pi r squared. And the area of the curved surface, so the area of the curved surface is pi r L. And the total surface area now will be the circular base plus the curved surface, which is going to give us pi r squared plus pi r L. We can still factorize this since pi r is common, so we have it as pi r into r plus L. And that is it for the surface area of a cone. Remember, if it is a hollow cone, that is the circular base is not covered, to calculate only the curved surface, you just concentrate on this pi r L to give you the curved surface area. So we should note also that since this is a right angle triangle, if you combine the height, the radius and the slant height, it is a right angle triangle. We can see that from Pythagoras theorem, L squared is equal to h squared plus r squared. And that is what we can have for the surface area for now. And we now go for the volume of a cone. Still maintaining the existing cone with height h unit, radius r unit and the slant height. Volume of a cone is believed to be derived from volume of a cylinder, and it is believed to be 1/3 of the volume of a cylinder with the same height and the same radius. So we have it as 1/3 pi r squared h. So that is the formula for calculating the volume of a cone. And now we go ahead to solve some problems on area and volume of a cone. So we take our first problem. Calculate the total surface area of a solid conical object of vertical height 24 centimeters and diameter 14 centimeters. Take pi equal to 22/7. So the solution to this problem, we have to calculate the total surface area. So the formula for the total surface area we just established is pi r into r plus L. So we now substitute in the values of pi to be 22/7. The radius is going to be obtained from the diameter here, which is going to be diameter divided by 2. And the slant height is not given. So we use the relationship between the slant height, the vertical height and the radius to get the value of the slant height. So the slant height is L squared equal to h squared plus r squared, and our h is 24, so we have it as 24 squared. We said our radius is diameter divided by 2, which is 7, so plus 7 squared. 24 squared is 276, and 7 squared is 49. 576 plus 49 is 625. Therefore, L is square root of 625, which gives 25 centimeters. Now, to calculate the total surface area now, we substitute in the values of pi, radius, and the slant height. So our pi is 22 over 7, and the radius is 7, so times 7 over 1 into 7 plus 25. So we have 7 cancelling this 7, we'll be left with 22 times 32. 22 times 32 will give us 704. That is 32 times 2 is 64. So 64 will give us 704 squared centimeters. So we go to problem 2. For problem 2, the cardboard paper in the form of a sector of a circle is folded to form a cone of vertical height 10 centimeters and slant height 6 centimeters. Calculate the area of the cardboard paper used to form the cone. Leave your answer in terms of pi. So we have seen from the net of a cone that it is in the form of sector of a circle, which forms the curved surface area of the cone. Therefore, in the solution to this problem, we are only interested in finding the curved surface area of the cone, so that the area of the cardboard paper used is going to be pi RL. Since we are to work in terms of pi, so we have our radius. Oh, we are not giving radius here. So we are not giving radius, we are giving the vertical height and the slant height. We are going to use the relationship among the 3 items. So that's going to give us R squared is going to be H squared minus L squared. So that our H is 10. So we have 10 squared, and our slant height is 6. So minus 6 squared. This is 100 minus 36. That gives 64. And the radius now will be square root of 64, which is 8. So we now find the area of the cardboard now to be pi times R, which is 8. So times 8 times L, and our L is 6. So multiply by 6, and that will give us 8 times 6, 48 pi centimeters squared. So we have successfully calculated the area of the cardboard used to form the cone, that's the curved surface area, and in terms of pi. So that's the end of solution to problem 2. So we go to problem 3. For problem 3, calculate the volume of a conical object of radius 15 centimeters and vertical height 21 centimeters. We are to take pi to be 22 over 7. So in the solution to this problem, we are interested in the volume of a cone. That's V equal to 1 over 3 pi R squared H. And our radius is 15. The vertical height, everything is complete here. So we have 1 over 3 times 22 over 7 times radius 15 squared, and multiply by height, so that's multiply by 21, and 3 times 7 is 21. We have 21 here, so this 3 times 7, which gives 21, will cancel this 21. We'll be left with 22 times 225. We are going to use mental mathematics method to simplify this. We just multiply 222 by 2. That will give us 450. Then 450, we leave 1 digit and arrange it in this way. We then add. So in our addition, this is 0, this is 5, this is 9, and this is 4. So the volume of this conical object will be 4,950 cubic centimeters. So this is the end of solution to problem 3. So we go to problem 4. For problem 4, a solid cone has a vertical height 12 centimeters and base diameter 10 centimeters. Calculate the slant height, surface area, volume, mass of the cone if its density is 2 grams per cubic centimeters. Take pi to be 3.14. This is a complete problem of a cone. We are going to find the slant height, the surface area, the volume, and additional information, that is the mass of the cone given the density, and we are going to use the density plus the volume we are going to calculate to find the mass. So let's go to the solution of the problem. We are given a relation connecting the slant height, the vertical height, and the radius. So that's going to give us L equal to h squared plus r squared. So this is going to give us 12 squared, that is the vertical height, and the diameter is 10 centimeters. So the radius will be 5 squared. This is 144 plus 25, which gives 169. So L is going to be square root of 169, which gives 13 centimeters. And we now go to B part of the question, that is the surface area. The surface area now is going to be the total surface area. We already have it as pi r into r plus L. And we are going to substitute in the values of pi, r, and L. So that's 3.14 times 5 into 5 plus 13. That will give us 3.14 times 5 times 18. Since 5 plus 13 is 18, that's 5 times 18, 90 times this will give us 282.6 squared centimeters. And we have done justice to surface area of the cone. We now go ahead to find the volume of the cone. Volume of the cone is 1 over 3 pi r squared h, and our pi is 3.142, our radius is 5, and our height is 12. Substituting this, we have 1 over 3 times 3.14 times 5 squared times 12. This 3 here goes 1, 3 goes here, 4. And if you look at it, 5 squared is 25 times 4 is 100. So 100 multiplied by 3.142, we just remove the decimal point. We have our answer as 314 cubic centimeters, which represent the volume of the cone represented in problem 4. So we now go ahead to find the mass of the cone using the volume we just calculated multiplied by the density, which we are given here. So that will give us 314 times 2. 314 times 2 will give us 628. So that gives 628 grams. And that's the end of solution to problem 4. That is the highest we can go in this tutorial. I hope you enjoyed it. Like and share this video. Also remember to subscribe to our YouTube channel, Uninab Resources. Check the description section of this video on our YouTube channel to get links to other topics on geometry of solid shapes. Until I come your way again, goodbye.